Good morning, students. Today we'll discuss SAQs from thermodynamics. This is the last lesson, 4 marks question. Thermal properties of matter and thermodynamics. From these two lessons, you can get one SAQ. Today, first question, first law of thermodynamics. State and explain first law of thermodynamics. State and explain first law of thermodynamics. In this one, statement. This question you are reading in chemistry also. So from chemistry and physics, from both subject sides, this question is the important question for 4 marks. They're asking state and explain first law of thermodynamics. Statement. For example, this is the heat dq. dq is the heat, some amount of heat supplied to the system. Heat, okay, heat given to a system. This heat utilized for two cases. One is increases internal energy. Supplied heat always equals to sum of two energies. Internal energy plus work, external work. Sum of internal energy plus external work always equals to supplied heat. Heat always equals to sum of increase internal energy and external work. dq equals to du plus dw. This one only law of conservation of energy. So we are writing heat supplied to a system, heat given to a system. Anything, no problem. Heat supplied to a system is equals to sum of increase internal energy plus and external work. Always supplied heat equals to internal energy plus external work. This is first law of thermodynamics. dq equals to du plus dw. Here, this one statement, student, heat supplied to a system always equals to internal energy plus external work. For this one, explanation statement nearly same. Supplied heat is the dq. We are writing like this. When dq heat supplied to a system, it is used to increase internal energy. dq is the supplied heat. It increases internal energy, meaning part of energy for internal energy, remaining for external work. So we are writing always supplied heat is equals to sum of internal energy plus external work. This one only, again we are writing dq equals to du plus dw. Now for this one, sign convention. Sign convention out of 6, you write any 4 points enough. Sign convention. Sign, otherwise sign symbols enough. What is that sign symbol means here? First point number 1, related heat. When heat supplied to a system, dq is the heat given to a system, heat supplied plus heat taken from the system, negative. So heat given to the system, dq, nothing but heat given positive. Heat taken from the system, negative. Heat given means positive, heat taken means negative there. This one sign convention, student. One is heat given means plus, heat taken means minus. Increase internal energy. Increase internal energy. Nothing but du equals to positive. Energy increased, positive. Decreased, negative. First one, heat given plus, heat taken from the system minus. Increase internal energy plus, decrease internal energy minus. This third one, listen somewhat carefully because chemistry and physics quite opposite. Work done on the system, work done on the system, on the body, anything, no problem. Work done on the body, negative. Work done by the body, positive. Work done by the body, positive. This sign convention you are taking in chemistry quite opposite because that is the chemical equilibrium concept. This one, thermodynamical equilibrium. Again, I'm repeating this one, overall law. What is the importance if this law means? This one, consequence. Consequence means other form. Consequence of law of conservation of energy. Overall question like this: state and explain first law of thermodynamics. State and explain first law of thermodynamics statement. Heat supplied to a system always equals to heat energy always equals to internal energy plus external work. This one only law of conservation of energy. Supplied heat dq. Internal energy is the du. Heat supplied to a system, it increases internal energy and remaining part of external work is there. dq equals to du plus dw. Sign convention, any two sign convention, right? No problem. At least one. First statement 1 mark, explanation 1 mark, sign convention 2 mark, total 4 marks. Heat given to the body, heat given to the system plus, heat taken from the system minus. Increase internal energy plus, decrease internal energy minus. Work done on the body, negative. Work done by the body, positive. This is nothing but other form of law of conservation of energy. So student, this question in supplementary examination for 4 marks question is coming for 4 marks. State and explain first law of thermodynamics. Okay, this is the first question for this day. Now second one. Second question, explain Celsius, Fahrenheit scale relation in between them. This is the second question from heat, previous first law of thermodynamics. Now explain Celsius and Fahrenheit scales with what is the relation in between them. First of all, what is the purpose of this topic means just thermometers. You take any thermometer, for example, this is the thermometer. For any thermometer, lower fixed point is there, upper fixed point is there. For example, you take 15 centimeter scale. For that 15 centimeter scale, least value is the 0 onwards. Highest value is the 15. In mathematics integration, we are taking lower limit is there, upper limit is there, like that. Celsius scale, for this Celsius scale, 3 points. Celsius scale, nothing but this is the Celsius scale, 0 degree Celsius, 100 degree Celsius. Number 1. What is the lower fixed point? Lower fixed point in Celsius scale, 0. Upper fixed point is 100 degree Celsius. So Celsius scale means least value is the 0, highest value is the 100. This one we are calling ice point. This one steam, stream, both are different. Steam point. Now what is the calibration? Division means it divided into 100 parts, because 0 to 100, 100 minus 0, we can get individual 100 parts. Each part is 1 degree Celsius. Finally, 3 points we are getting from Celsius scale. In Celsius scale, lower fixed point is the 0 degree Celsius. Upper fixed point is the 100 degree Celsius. One is ice point, one is steam point. It divided into 100 parts. Each part 1 degree Celsius. This is nothing but Celsius scale. Next, Fahrenheit scale. So Fahrenheit scale, same. Lower fixed point is the 32 degree Fahrenheit. And in this one only same. Upper fixed point is 212 degree Fahrenheit. Understand variation? Divisions 180. It divided into 180 parts. Each part 1 degree Fahrenheit. Finally, explain Celsius and Fahrenheit scale means Celsius scale 3 points, Fahrenheit scale 3 points, relation 2 to 3 step. We can get answer. Answer very easy answer, student. Explain Celsius and Fahrenheit scale. What is the relation in between them? Lower fixed point 0 degree Celsius, upper fixed point 100 degree Celsius. Each division 1 degree Celsius. Total how many divisions means 100 parts, 100 divisions. Lower fixed point in Fahrenheit scale 32 and upper fixed point 212. Divisions 180, each part 1 degree Fahrenheit. Now, what is the relation in between Celsius and Fahrenheit scale? Relation between Celsius and Fahrenheit scale. Now, here student, S minus LFP by UFP minus LFP equals to constant. For any scale, what is the fixed formula means? S minus LFP by UFP minus LFP equals to constant. What is the meaning of this one means? Total 4 different scales we are having. Celsius scale, Fahrenheit scale, Kelvin scale, Rankine scale is there, Reamer scale is there. So that Rankine scale is the old scale, student. We are doing few problems on Reamer. Total all type of the scale, single formula. Any scale you take, and one more there, triple point scale also, student. One more, triple point scale. So S stands for scale. In Celsius scale, S nothing but C. What is the lower fixed point in Celsius scale? 0. Upper fixed point 100 minus 0 equals to constant. This is for Celsius. Fahrenheit means scale F, least point 32, highest point 212 minus 32 equals to constant. Constant, right side means obviously LHS also constant. C minus 0, C. 100 minus 0, 100. F minus 32. 212 minus 32, 180. Our answer came 0, 0 cancel, 2 5 ja, 2 9 ja. C equals to 5 by 9 into F minus 32. Enough up to here. Remember they are doing derivation, this one also. But this one waste up to here over. Celsius with Fahrenheit scale. Now, here student, first question, explain Celsius and Fahrenheit scale relation in between them. Celsius scale, lower fixed point 0 degree Celsius, upper fixed point 100 degree Celsius. Divisions, total 100 divisions, each division 1 degree Celsius. Fahrenheit scale, LFP 32 degree Fahrenheit, UFP 212 degree Fahrenheit. Divisions are 180, each part equals to 1 degree Fahrenheit. Relation, any scale S minus LFP by UFP minus LFP equals to constant. This formula belongs to all cases, student. S stands for scale. C is the scale in Celsius. F is the scale in Fahrenheit. Least point 0, highest point 100 from Celsius side. Least point 32, highest point 212 from Fahrenheit scale. Just equating, we can get C equals to 5/9 into F minus 32. This is the relation in between Celsius scale and Fahrenheit scale. Today, up to now, 2 questions over. One is the first law of thermodynamics with sign conventions, relation between Celsius and Fahrenheit scale. All these topics from heat lesson. Now, next question number 3 for this day. Now, see. Explain conduction, convection, radiation. This is the question number 3 from heat lessons, thermal properties of matter, students. So, explain conduction, convection, radiation. First, thermal conduction. Just one. Convection. Then 1 point. Radiation, 1 point. So, what is the meaning of conduction means? For example, you take solids. Solids, nothing but molecules are closely packed like this. Molecules are closely packed. Like this. Just we are supplying heat. Here we are giving heat. Like this, slowly it transfers. When we are supplying heat, heat always flows from hot body to cold body. So this molecule absorbs heat, gives to this one. This one gives this one, this one gives this one, this one, this one, this one, this one, this one. Slowly, total heat transfer from left side to right side. This one only conduction. What is the meaning of thermal conduction means? Heat flows in solids. Heat flows without actual movement of particles. Heat flows in the substance without actual movement of particle. This one absorbs, gives to second one. This one absorbs, gives to third one, like this, like this, like this. That's why we are writing flow of heat in solids belongs to which one is there? Thermal conduction. But you are writing definition, heat flows. Heat flows in the substance. Heat flows in the substance without actual movement of particles. So, student, example, flow of heat in solids. Flow of heat in solids belongs to thermal conduction. Without actual movement, that is the most important word. Convection. Same. One more example to take. Water. Like this, we are supplying heat. When we are supplying heat in fluids, liquids come gases, collectively we are calling fluids. So hot water goes up, cold water, hot water going up, cold water coming down, hot water, cold water, like this. Molecules are up and downs we are getting. This is called heat flows in the substance with actual movement. Without actual movement, in previous case, with actual movement, meaning, see, heat flows in the substance with actual movement. Previous without, now with actual movement of particle. Example, flow of heat in fluids. Flow of heat in fluids. So student, one is without actual movement, nothing but due to molecular collision, meaning this one generally. But we are not going that much depth. Just according to IP level, we are writing words. This one with what is that molecular collision heat flows? This one density difference. We are writing that one means again this is looking like very big answer. That's why we are writing simple words without actual movement, with actual movement. In the case of solids, in the case of fluids, majority people they are thinking fluids nothing but liquids. Don't think like that. Fluids nothing but which flows. Liquids flows, gases also flows. That's why liquids and gases collectively we are calling fluids. Radiation, heat flows in space without medium, meaning heat flows in space, meaning in the absence of medium. For example, heat flows from sun to earth. Which type of process means radiation, meaning heat flows in the substance, heat flows in between the bodies, heat flows in space, meaning no medium. There is no medium required for flow of heat. That is nothing but radiation, student. Example, heat flows from sun to earth, not earth to sun, because sun is the star, self-luminous body. Earth is the non-luminous body. Sun, nothing but star, it emits radiation. From sun to earth, radiation coming with radiation process, that thermal radiation, heat. Heat flows from sun to earth by using radiation process. So, explain conduction, convection, radiation. Conduction, without actual movement, that is the most important word. Convection, with actual movement. Radiation, in the absence of medium. This is flow of heat in substance. Explain conduction, convection, radiation. Okay, students. Now here, in this one, more few questions left. One is first law of thermodynamics. Today, first question. Second one, explain Celsius Fahrenheit scale. What is the relation? Next, explain conduction, convection, radiation. Next question, student. Fourth question. Anomalous, otherwise advantage of anomalous behavior of water. Advantage of anomalous behavior of water. So what is the advantage of anomalous behavior of water? Total 4 different points here, student. Total 4. Before that one, what is the anomalous behavior of water? Listen carefully, student. Depend on this one only we are going advantage. Advantage, total 4 points. This one especially for cold countries benefit, not for our country. First of all, what is the anomalous behavior? For water, special behavior is there. That is anomalous behavior. What is the anomalous behavior means? Very simple. You take any substance except water. On heating, either contracts, otherwise expands. For example, take metals. On heating, metals expands. For example, you take polythene cover. You take leather. You take rubber. On heating, it contracts. Like that, one substance on heating either contract, otherwise expands. But water sometimes expansion there, sometimes contracts. What is the reason for that one? Listen, that is only anomalous behavior. Just 1 minute there. Just you remember 4 degrees Celsius, because water maximum density at 4 degrees Celsius, depend on this one only, we are going towards advantage. For example, you take 0 degrees Celsius to 4 degrees Celsius, 4 to 100. Ice on heating, when we are giving heat to ice, from 0 degrees Celsius to 4 degrees Celsius, contracts. From 4 degrees Celsius to 100 degrees Celsius, expands. From 100 to 4, again contracts. Again from 4 to 0, expands. This is special behavior we are calling anomalous behavior, student. Finally, dilatometer experiment, that one removed from intermediate syllabus. Dilatometer says that water maximum density at 4 degrees Celsius. You remember water maximum density, nothing but more weight. Water maximum density at 4 degrees Celsius. About that 4 only our topic. 4 degrees Celsius, water maximum density. Depend on that point, advantage of anomalous behavior here, student. This diagram just to understanding purpose only. For this diagram, no mark. First point, in cold country, our country not cold country, our country hot country. That's why daily full, what is that, temperatures coming in summer. So you take in cold countries, cold country means, for example, you take Russia, you take Britain countries, USA, all these are cold European countries. In cold countries, sometimes temperature 0, sometimes surrounding temperature less than 0 also there. Our topic, what is the advantage of anomalous behavior of water means in cold countries. So in cold countries, sometimes temperature in cold countries, surrounding temperature less than 0 degrees Celsius there. Okay. First point, in cold countries, temperature decreases up to where 0 there, less than 0 also. Why we are saying 0 means 0 onwards, ice getting. That's why in cold countries, we are getting least temperature. Point number 1. Next, surrounding temperature. When surrounding temperature at 4, water becomes water maximum density, sinks bottom. See, first one, in cold countries, temperature falls, temperature decreases below 0 over when surrounding temperature is 4 degrees Celsius, student, because one particular place temperature 10, then after 9, then after 8, then after 7, 6, 5, 4. When 4 degrees Celsius means this is the lake. Example, take lake or pond, anything, no problem. 4 degrees Celsius surrounding temperature means 4 degrees Celsius water become more denser, meaning this water sinks down, meaning slowly this water coming towards bottom of the lake. What is the reason? 4 degrees Celsius. This is a natural phenomena, student. First point, temperature below 0 degrees Celsius. Second one, surrounding temperature 4, water become denser, sinks to the bottom. Now, temperature 3, 2, 1, 0 degrees Celsius there. At 0 degrees Celsius, at 0 degrees Celsius, upper layers forms ice, 4 over more denser, 3 not denser, student, again rises only, 2, 1, 0 degrees Celsius. When surrounding temperature 0, upper layers forms ice. Upper layer forms ice means effect of 0 degrees Celsius. Upper layer forms ice. Lower level maintains different temperature, student. Obviously, 4 degrees Celsius bottom. This one some 3, this one some 2, this one some 1 degree Celsius there. So, point number 1, cold countries temperature less than 0. Surrounding temperature 4 means water become more denser, sinks down, remaining rises up. At 0 degrees Celsius, upper layer forms ice, bottom layer maintains same temperature. At bottom, 4 degrees Celsius least. So, fourth point, at 4 degrees Celsius, aquatic animals are protected. This is the anomalous behavior advantage, student. 4 points without diagram. You are drawing diagram, you are not drawing diagram, not an issue. The diagram only understanding purpose. This one very simple concept. Just 4 lines in 4 into 2, 8 seconds. Cold countries temperature below 0 over 1 point. Temperature, surrounding temperature 4. Water becomes more denser. Point number 2. Point number 3, at 0 degrees Celsius, upper layer forms ice over. Fourth point, bottom layer at 4 degrees Celsius, aquatic animals are protected. This is the advantage of anomalous behavior of water. Students, now see one more last question for this day. First of all, today, first question, first law of thermodynamics, supplied heat is equals to sum of increase internal energy plus external work. Next, explain Celsius Fahrenheit scale. What is the relation? Explain conduction, convection, radiation. This is the question number 3. Anomalous behavior. Advantage of anomalous behavior of water. For water only, anomalous behavior. One more question, student. Triple point. After this triple point, just 2 questions left for tomorrow class. One is relation between molar specific heats, Cp minus Cv is equal to R. Last one is there why Cp greater than Cv. Just 2 SAQs left. LAQs over, SAQs over, 1 or 2 days VSAQs enough. So, annual exam, sorry, supplementary examination purpose, you are reading 4 SAQs, LAQs. SAQs, how you are reading SAQs? I will give you number wise. 11th bit, which number, which questions coming? 12th bit, which questions coming? 13th, 14th, 15th, 16th, 17th, 18th. Total 6 questions coming. You are writing any. Sir, total 8 questions they are giving. You are writing any 6 because 2 choice. Then after VSAQ student, VSAQs means 6 VSAQs from 3 lessons. Out of 10, 6 VSAQs coming from 3 lessons. One is the mechanical properties of fluids, 2 VSAQs. Thermal properties of matter, 2 VSAQs. Kinetic theory of gas, 2 VSAQs. Total 6. Remaining 4. One is from rotation motion, otherwise units. One is physical world. Next one is the laws of motion. Okay. These are the VSAQ student. Physical world 1, units and measurement 1, laws of motion 1, rotational motion 1. 4 plus 6, total 10. Now see, last question, triple point of water. First triple 3. For water, 3 states present: solid state, liquid state, gaseous state. What is the triple point of water means? In phase diagram. In phase diagram, at 610 Pascal pressure, 273.15 or 16, anything, no problem. At this pressure, at this temperature, solid, liquid, vapor of water coexist. Coexist nothing but equilibrium. So student, in phase diagram, at 610 Pascal pressure, 273.16 Kelvin temperature, solid, liquid, vapor of water in equilibrium. Solid, liquid, vapor of water coexist. That is nothing but a triple point. For this one diagram present. O, other way take O, A, B, C. This is temperature. This is pressure. This is the solid, liquid, vapor. Ice line, steam line, hoarfrost, sublimation. Anything, no problem. Light. Now, see our student. First definition, 1 mark. Diagram, 1 mark. This 3 concept 2. Total 4 definition. In phase diagram at 610 Pascal pressure and 273.16 Kelvin. Solid, liquid, vapor coexist or equilibrium. Don't draw from origin. The origin is there. Now see student, OA, like this, see. This is OA, ice line. Ice line, negative slope, because left side coming negative. Solid, liquid, equilibrium. What is the meaning of ice line means? Solid, liquid in equilibrium state is there. That is ice line, one ice line. Next one is the OB, positive slope, liquid, vapor. OB, steam line. This is positive slope. Nothing but liquid, vapor coexist. Solid, liquid coexist, ice line. Liquid, vapor coexist, steam line. Solid, vapor coexist. That is nothing but sublimation line, student. This is CO, don't go like this OC, CO. CO, positive slope. 2 positive slope coming, 1 negative slope coming. Ice-line, solid liquid. Streamline, liquid vapor. Negative slope, CO. Solid to vapor is the sublimation, vapor to solid is the hoarfrost. That's why go anything, no problem. Solid comma vapor. Which line? Sublimation line. So student, this is the triple point of water. Definition starts with pressure and temperature. 610 Pascal pressure, 273 Kelvin temperature, solid, liquid, vapor of water coexist. This is the diagram. Diagram compulsory because you can get 1 mark for this one. One is ice line, next one is the streamline, third one is the sublimation line. After this, more 2 SAQs left. One is the Cp minus Cv is equal to R. Next one, define Cp and Cv. Why Cp greater than Cv? Last 2 SAQs left. Tomorrow, I will finish. I want to explain that 2 4 marks. Then after VSAQ zone student, maximum 2 or 3 classes enough. Okay? Right? We'll continue tomorrow.